Hello all and welcome back. So in this video, we will continue our discussion on stacks and now try to implement our own stack using the inbuilt Python list. So let's get started. Now, when I talk about implementing stack using list, the basic idea is that I will be giving just these 5 operations which we talked about through which my stack is defined. Okay, so let me just explain you a little bit on this. In the backend, to store the data, I will still be using a list like this. Okay, so to store the data in the backend, we will be using a list. But the idea is to restrict the operations of my list. Okay, now anytime you have to visualize stack, please do so in this particular manner so that you can do all the operations, right? Let me draw it. So this is how we should visualize our stack. Now we have already seen how these operations are performed, right? But first let us try to see what our list gives to us. So let's say if I'm defining a list, okay, let's say I'm defining a list with name stack. Okay. Now if I do stack dot, then we have so many operations. We can append, we can extend, we can even insert in some position, we can remove from some particular position. Pop is there, which is of course the one which we can use. Okay. But based on our discussion, these are not the operations which I want, right? These are not the operations which I want. So if we have to then do the same thing, then I think we all know how we can use the same. We can make our own custom data type. Now, classes are how we achieve the same thing, right? So classes, using the class concept of OOPS, we can create our own custom data type, and that is something which we are going to use. So let me now define a class, everyone. Class stack using list. Okay. Just a disclaimer here. If any one of you have not seen the OOPS module, will highly suggest that you see that once. The reason is that we are going to use classes a lot going forward to implement our data structures from scratch. It is very important that one should have an idea how the data structures are implemented. Okay, that actually expands your horizon, and you can then think of different implementation yourself as well when you are defining classes tomorrow in some project. So now let us go back to our coding. What I'm suggesting is that we will still be using a list, but we have to somehow just make sure that we are limiting the access to functions, right? The idea which I have is I'm going to make a stack using list class. Okay. I'm going to use the variable, use an object of this particular class, which will just have those 5 functions. Now, my end user doesn't have to worry how exactly I'm doing it. But internally, we will be storing the data in our list still and making sure that we can mimic the behavior of my stack overall. Okay. So let us do that one by one, everyone. Then the very first thing, I will be defining a constructor, which is going to be something like this. One second. Self dot stack, which is an empty list, right? So as of now, I am assuming that when you make an object of this class, you will be having an empty stack, right? An empty packet to start up with, where you can now insert anything which you want. Okay, great. So cool, everyone. Let us now implement all those operations one by one. Please make sure that you understand each and every one of them a lot in depth. Once you understand them, then it will be a lot easy for you to implement as well. Great. So the very first operation, I think, which is a lot easy as well, what we can do is we can do push operation, right? We can do push operation. I will be giving some self and some data to push, right? So let us see that what exactly push is. Let's say for the time being, I have this element 1, which I want to push in my stack, right? Which I want to push in my stack. So very first operation, let me write down here as well, is going to be push. Now, using list, the same is of course very much easy. What we can do, if we have to insert anything to the end of our list, we just use to self.stack. This is my list dot append, and I can say data, right? It's going to actually just append or add this data to end of my list. The idea will be that somehow I can maintain my list like this. So pay attention everyone. Like let's say if I've inserted 1, then it will be here, then 2, then 3. But I will be limiting access so people can only either see this or remove this, or they can add here. So that is the major idea. As we will move forward, the overall concept will become clear. So this is how we can push. Okay. If we want, for our understanding, we can maybe print that, let's say pushed data. Okay. Or let's say this into stack. Okay. So we have pushed this into stack. Great. So the next one, which again is very easy, I think, can be the size of your stack, right? So if you ask this size, what I have to do, I have to just return self dot stack and length of this, right? Length of this stack. So again, let me just explain a little bit on this as well, everyone. If we will have 3 elements here, let's say if I will have 3 elements in this, for the outside user, this is how he will imagine. But for me, as I am the one who is implementing, I am storing it like this. If I just get the length of my list, which we know is an inbuilt function, we can tell that how many elements are there in my stack. We just have a single list we are maintaining. So length is the size of my stack. When we started off, the list was empty and the length was 0 as well. Okay, great. So this is going to be our size, everyone. This is going to be our size which we are returning. Next one which we can do again is very easy, is empty. So again I will be getting a self. So how I can do is empty if length of self dot stack equals 0. My bad, equals 0. If this is the case, then I can return true, else I can return false. Again, see what I've done here. I am saying if the length of my string is 0, right? That means my stack is empty. Just a simple check. If you don't have anything in your stack, then of course your list, which I am maintaining, is going to be empty. Just the way when we initialized it. It will be like this. And if it is like this, then we can say that it is empty. On the other hand, if it is not the case, then we will return false. Now, I think many of you must have an idea that I can write this in a single line as well. So length of self dot stack equals 0. So just to make it a lot more easier to read, maybe we can use this one. Okay, so I will leave this particular implementation as well. Uh, Pretty sure this will be a lot easier to get now. Great. So cool. Now let us move forward, everyone. What was the next operation which we can do? We have done push, we have done size, we have done is empty, right? Next operation which we can do can be top, or we can say it peak as well, where I have to just return the topmost element of my list. Okay, so let us discuss a little bit on this, everyone. Let's say if I have a list, right? Let me just do it here. Yeah. So top. Okay. Let's say if I have a list like this 1, 2, 3, 4, and 5. Okay. If I want to get the last element, which is going to be this element, how can I do that? If my list is L1, just a second, everyone, let me make it a little bit more clear so that you all can understand. Let's say L1 is equals to 1, 2, 3, 4, and 5. Okay. I know the length of L1 is going to be 5 as well. Okay. Now, if I want to access this particular element, how can we do that? So I will write the question as well. How to access the last element of our list. Okay. So you can pause and think about this for a second. Pretty easy this would be if you have done all the previous module. If not, we'll just request you to see the list module. Okay, great everyone. So pretty sure you must have given this thought. Now, if I want to get the last element, I think I have two ways. The first way can be I can do L1 of 4, right? Because I know this is how my indexing works. 0, 1, 2, 3, and 4. Okay. But again, this 4 is not something, so I cannot write like this. Return self dot stack of 4. I cannot say it like this, right? Because what if the size is 6 tomorrow? Like if there are 6 elements tomorrow. So I hope all of you know this formula. Like this is pretty easy, not even a formula. I can say L1 length of L1 minus 1. Okay. So this is what we can do. And there is another way. Python being how awesome it supports negative indexing as well, right? -1, -2, -3, like this. So I can directly just do actually, I can directly just do something like this. L1 of -1. Okay. L1 of -1. So I hope each and every one of you are able to understand this. This is just a basic indexing stuff. So I will be using this -1. Although in comments, to make sure that everyone remembers, I will be just also writing this self.stack length of self.stack -1. This is also absolutely fine. One thing, let us just try this out once. Python. Okay, and let us just say this test Python. Great. Let's say if I have a list like this, 1, 2, 3. Okay, and I write L1 of -1. I should be able to get 3. Okay, let me. I will have to print this, not in Jupyter Notebook. See everyone. Once again, yeah, I'm able to get 3. Okay, great. But what if my list is empty? What if my list is empty and then I try to access the last element? So this is analogous to you are saying that your overall can of Pringle is empty and you are trying to look or get the top one. You are like trying to see the top one. I don't think you will see anything. It is giving an error. In list index out of range. This error effectively mean that if it is empty, how can you try to access or even see the first element? It is not there. So this is some condition which we will have to make sure we handle. So what we are going to do everyone, if now to check if it is empty, I can just directly call this if self dot is empty, self dot stack, then I should ideally print an error, right? So we can say that stack is empty, no top element, right? I hope all of you are able to understand this and we can just return maybe none. So this will signify that, hey, why are you trying to see what's on top of an empty stack? It is not there. Okay, everyone. So I hope this is clear exactly what happened here. Let me zoom out and see. Okay, great. So I hope the top is also clear. Now we have done 4 of these operations. Now, if this was done, we can very easily do pop as well. Okay, pop is actually something which is already present in my list, right? So we can use the same, or we can just get the top and remove the last element. I'm going to use the list inbuilt one. So what we can do, return self.stack.pop. Okay, so let us see this everyone. If this also works the way we expect it to be, 1, 2, 3 dot pop, and let me just print L1 after that as well. So yeah, great. I think it is working. Okay, I think it is working. How we know that? Because my list was like this. 1 second. Yeah. So my list initially was 1, 2, 3. When I popped, it just threw that element out. So it is not that we just want to see now. Pop means that, hey, delete or rather remove the element and give it back to me as well. It is just analogous to you getting that chips, okay, out of your particular Pringles can, or you getting that top bread out of your overall bread packet. Okay, so I will write it down as well because these are the major one. Size and everything is lot easy. So third one now is pop. Okay, so it means getting the top element and removing it as well. Removing it as well from our stack. Okay, everyone. So we are getting that element and we are removing it as well. Now, if that's the case, if we are dealing with top, then I think all of you will understand one more thing, that I should have this condition, right? How can you then ask me to pop from a empty list? See, it's giving an error. It printed out empty and it's saying that pop from an empty list. You're doing something wrong, right? So great, everyone. What we can then do, just the same condition. Okay, I hope each and every one of you are able to understand, okay, that why this condition is getting used. Again, giving you intuitive example as well. So make sure that you try to just follow that and you will be able to write these codes as well. Great. So yeah, I think we have given all these 5 operations which we were required. Now let us try to create an element and try to see how our stack is going to behave. So let's say my stack is going to stack using list. Now see the very first thing, everyone, my stack dot. Are you able to see that just 5 operations are there? Top, size, push, pop, and is empty. These you can of course ignore. They are the inbuilt one magic methods. Now, if I just do is empty, okay. So what? Let us do something. Let us check our overall stack, the one which we have created, if it is working the way we want. My stack dot push. So I am pushing one into this. I am pushing, let's say, multiple elements. Then I'm checking again if it is empty or not. Then I am popping some elements. Let me pop 2 elements and let me then get the size. And just last one which we can check as well is the top. Okay, great all. So first let me explain how exactly this will go. Okay, so till now I will just repeat what all we have done. By our basic understanding of stacks and the operation involved, we have tried to implement the same very patiently using our inbuilt list. Our whole aim is to make it abstract, which I think we have achieved because this class is just giving me the operations which are possible on stack, right? Although internally I'm using list, that is not a problem. For an end user, he will be able to use a stack. Great. Now, post that, what exactly is happening? Once we have done this, we are now trying to check the particular working. When you want to check a stack, we will be drawing it like this stack only. Okay, so this is the stack which I will be drawing. Now, when I check if it is empty, this should return true because as of now, I have just created and nothing I have entered. Then I am entering 1. Okay, I'm entering 111. So let me make it 1, 2, 3, and 4. So at this point, I have entered 4 elements in my stack. Again, you don't have to think in terms of list. Think it as a stack only. Then you check if it is empty. So it's going to be false. Then we pop. So it's going to be 4 and 3. Size at this time, when I remove these elements, I think it's going to be 2. And the top is also be going to be 2. Right? So let me just correct this particular thing, everyone. Let us just push 2, 3, and 4. Okay. Great. So let us try to run this now. 1 second. Where are we getting an error? Is empty takes 1 position argument, but 2 were given. Okay, where have we asked self is empty? 1 second, everyone. Let us quickly check where it is saying that 2 arguments were given. Mm, okay, my bad. We cannot call this. Now we don't have to give stack here. So self will go by default. So I don't have to check that. Cool. So great, everyone. I hope you understand the error. So we were giving in this self dot is empty. First self will be passed and we were giving a stack as well. We don't need to do that. That this is empty has an access to this stack, right? Great. So just to keep this, yeah. So this was the order. Okay. Great, everyone. So let us run this. And I think now we are working fine. So it is true, the first one. Then we are pushing one into the stack. We are not returning anything, so none is getting printed. Then push two into the stack, then none. Then push three into the stack, then again none. Pushed four into the stack, again none. We can handle this none as well, should be fine. It's just that because we are not returning anything, by default it is returning none, which is something which we are printing. We should ideally not print this operation because it is not an operation which should be printed. Great. Now we ask if my stack is empty. Well, it is not because we can see it is false. Then we popped. So pop is first element. Get me the first element and remove it from the stack. So it is 4. Then we pop again. It is 3. Then we get the size. Size is 2 because as of now, these two are the elements which are present in my stack. And finally, top, which is 2 again. Okay, everyone. So I hope each and every one of you are able to understand that how exactly using list I have now worked on my stack. Now, one more thing which many of you might be thinking, which even I had the doubt on, is that I can still using my stack implement all these functions, right? So I can insert, let's say at 0, 10. And now if you do this particular thing, now if let's say we try to print my stack, then I think this goes a lot against of what we were trying to do. So I'm able to add towards the starting, right? I will repeat what I've just done. This stack is where everything is getting accessed, right? The stack is the list where everything is getting stored. These operations are fine, but I can also access this stack variable, this instance variable stack, and then actually get each and every operation which I want to do. So don't you think it is problematic that we are able to do this? Why is it I can clear all of them? Ideally, I cannot clear a stack. I should keep on popping until it gets clear. So for that, again, everyone, uh, let's go back to the oops basic. We can in Python make this kind of private. Now, there is a reason I say kind of private because nothing is completely private in Python. So this is now made private. Okay. If I am making this like this, then I hope all of you know that I have to use this only everywhere. So under underscore stack, under underscore stack, double underscore stack, and here as well, double underscore stack. So now everything seems to be fine. And if now I try to access this stack, it will give me an error. Okay, let us see this and run this code. See, it is giving some error. What is it saying? I think we have just avoid something. Yeah, my bad. We have missed it out something. Yeah, so we have missed it here. Okay, great. So pay attention, everyone. Again, let me make it 10, 20, 10, 20, 30, 40. So everything is fine. It is just saying that, hey, stack using list doesn't has any attribute stack. What are you trying to access? Can you please be sure? It doesn't have any attribute stack. Please be sure what you're trying to access. Okay. And now I think it's worked fabulously well. Now anyone who is making this stack can just get these 5 functions, these 5. Okay. So even if I try to do this under underscore stack, it's also going to give me an error because it has no attribute under underscore stack. So just here making it private and we have done this thing. Let me write it here. Very important to make it private so that functionality is right. Okay, everyone. So I hope you understood the problem involved as well as what exactly you can do to avoid the same. Okay. So yeah, that was all about the implementation of stack using a list. Pretty sure that it will be a lot clear to each and every one of you. What I will suggest now is to first implement it yourself at your end without seeing the code. It is pretty doable, I would say. Maybe not easy in the first go. I understand that. I also took a lot of time, like even after understanding, I took an hour to implement that properly. Second is try to run these commands first yourself and then just compare that with the result you are getting. In that way, you will actually understand that where you are making the mistake, and your overall understanding of stack will become a lot more clear. Okay, everyone. So I hope this is a lot understood now. Please make sure that you try to implement this same thing once at your end again. Okay. So once this is done, then we are going to see that how we can implement stack using more ways. Okay. Thank you.